Algebra 1, Solving Quadratic Equations. We're going to use graphs to identify solutions to quadratic equations, and then we're going to solve these equations algebraically. So first, what you will need to do is, if you haven't already done it, download the Desmos app for your phone. If you have a desktop, of course, you could go to desmos.com/calculator. But I'm going to go ahead and click Desmos because I've already downloaded my app. And so the first thing I want to do is I want to type in the left side of this equation. So we're going to open parentheses, x minus 2, close parentheses, and then exponent, and put your 2 there, or shift, just put a squared and it'll put the square. So that's the left side. So you now see a parabola. And if you'll click on 2, you can type in the right side of the equation, which is 9. Oh, wait a minute. Let me go back and put y equals 9. Y equals 9. All right. Now, it does give you the ability to set your range for that y value, but I'm gonna go ahead and leave that off. Now, you can't see this second equation in this graph, so you'll need to move it down. So I'm just going to drag it down, and now I can see a parabola and a line. Now, what's even better is I can close that, and I can see it better. And you can also zoom in. If you'll zoom in enough, it'll pop up those points. I think what I want to do is count by 1. So let's change this. Take off these minor grid lines, and I'm going to count by 1s here. Count by 1s here. Oops. And let's do, let's put our labels. So we'll put an X and a Y. All right, so now that I've set that up, I don't really need to do it again. The reason I did that is I like to see all these units on my graph. So I zoomed in so I can see all the units. Now, if you'll type, just press the points of intersection. It will highlight those points for you. And so the rest of this we're simply going to do on paper today. So notice we have a parabola, and that parabola is intersecting a horizontal line. So I'm going to do my little graph right here. I'm going to label my x-axis x and my y-axis y. And then I'm going to put my parabola, which actually you'll notice it touches the x-axis at 2, so that's kind of interesting. So I'm going to make my parabola do this. So there's my parabola. And then I'm going to draw my horizontal line up here. Now you'll notice I'm not putting any scales. I don't really need all that information. What I really need are these 2 points of intersection. So we're going to put the points of intersection and label those here. So this point of intersection is -1, 9. And the other point of intersection is 5, 9. So the solution to the equation is where this expression is equal to this expression. Notice there is no y in this equation, so that values for y are not really important in this equation. But what are important are the values for x. So there's 2 solutions to this problem. One is x equals -1. That's your first x coordinate. Because if you put a 1 in here, you will get, or a -1 in here, you will get -3, and -3 squared is 9. And then the other solution is 5. If you put a 5 in here, 5 minus 2 is 3, and 3 squared is 9. So these are our 2 solutions, and we just found those with the graph. Now we're going to go back and we're going to solve this equation. So the way that we solve is we take the square root. So the inverse operation of squaring is taking a square root. So let's take the square root of the left side and take the square root of the right side. And so when you do that, it removes the parentheses, it removes this square, and we just get x minus 2. On the right side, this is something new. We have a square root of 9, but what you have to remember is since we're squaring something, we don't know if the number inside here was a +3 or if it was a -3. So what we do to compensate is instead of just putting a 3 here, the square root of 9, we put plus or minus 3. And we write it like that. So it could be either a +3 or a -3. Next, we're going to add this 2 to both sides to isolate our x. And so we have x equals 2 plus or minus 3. Now, you don't want to stop here because you need to go ahead and simplify this. And here's how you do it. You separate this into two statements. X is equal to 2 plus 3, and x is equal to 2 minus 3. Well, 2 plus 3 is equal to 5. So we already had that solution here, so that works. And 2 minus 3 is equal to negative 1. So we had that solution here. So notice we got the same two solutions, one by using our graph and the other by using our equation. Question 2. This time we have negative 2 multiplied by the quantity x plus 1 squared is equal to negative 8. So the first thing we're going to do is type this into our Desmos calculator. So if you'll click on this little double arrow, that'll bring your equation, your y equals basically. You're going to put in your left and your right side. So I'm going to go back and just delete this. And I'm going to put my negative 2 first. Oops. Sorry, I got to delete that one too, I guess. All right, negative 2, and then open parentheses, and then x plus. Yeah, there's something different here about our calculator. You might recall we could never use that subtraction on the TI calculator, but it's fine to use that on Desmos. They seem to make sense of that. Now, I forgot my y equals, so let me go back and put it, although I do believe this works even without that. All right, now let's go to the y2 and let's plug in the negative 8. So I'm going to put negative 8. Whoops, I did it again. I'm going to put y equals negative 8. All right. So now if I'll close this, I can see what I've got, and you'll have to scroll way down to see your two graphs. So I have a parabola and I have a horizontal line, and the points of intersection are the ones I want to pay attention to. So if you'll just double tap at the points of intersection, it'll pull up your ordered pairs. So notice the x coordinates are negative 3, negative 8, and 1, negative 8. So if I put a negative 3 in for x, I will get a negative 8 out, and that's why it's equal to the negative 8. And if I put a positive 1 in place of x, this left side will equal this right side. They'll both be negative 8. So what we'll do is we will go ahead and sketch this graph. And again, with not too much detail on this graph, let's keep it simple. But I do want to have a parabola, and you'll notice the parabola is touching the x-axis in just one spot, so that's kind of interesting. So here's my parabola. And then I need my horizontal line, so it's down here below the x-axis, so let's put a horizontal line going across here. And so the point of intersection is the points I care about. So I'm going to label those. So this point of intersection was negative 3, negative 8. And this point of intersection was 1, negative 8. So that means the solutions to my equation are going to be the x equals negative 3 and x equals 1. So let's write our solutions. X equals negative 3, x equals 1. Okay, now we're going to take the same problem and we're going to solve that algebraically. So we do inverse operations. So since this negative 2 is multiplied by this quantity squared, we want to get rid of the negative 2 first. We can't subtract 1 yet because it's inside these parentheses. We kind of save those for last. But we can get rid of this negative 2 because it's multiplied times this whole quantity. So if we divide both sides by the negative 2, so I'm going to write this problem over here so I can do my work on the right side. So negative 2 times x plus 1 squared equals negative 8. If I divide this by the negative 2 and I divide this by the negative 2, these are multiplied together, so I can divide out the common factor negative 2. So that's like a 1. Negative 2 divided by negative 2 is 1. And then over here, I can divide these numbers. So negative 8 divided by negative 2 is 4. So what I'm getting is x plus 1 quantity squared equals 4 for my next step. Okay, the next step in the process is to eliminate this square. This plus 1, I can't eliminate it yet because it's being squared, so I have to take care of the square first. The opposite or the inverse operation for squaring is square rooting. So we're going to square root both sides of the equation. When we square root this side, it basically eliminates the parentheses and it eliminates that square. So all that's left here is x plus 1. And on the right side, just like before, I don't know if the number in the parentheses was a positive or a negative, because if you square a positive or square a negative number, you still get the same result. So in this case, I'm going to put plus or minus 2, because positive 2 squared is 4 and negative 2 squared is 4. And then finally, we're going to subtract our 1 from both sides. So to subtract 1, you will write it this way: x equals negative 1 plus or minus 2. So I'm putting this number and then this plus or minus 2. Now let's break this up. If we break it up, we'll get x equals negative 1 plus 2. And negative 1 plus 2 is equal to positive 1. So this answer we have already written here. I'm just going to draw an arrow up to this answer. So I'm checking my answers basically as I go by looking over here. Now this other answer is x equals negative 1 minus 2. So I'm going to write that out. X equals negative 1 minus 2. And if you add negative 1 to negative 2, you do get negative 3. So this answer is all the way over there. So I did get the same result when I solved the equation algebraically. Okay, question number 3 is quantity x minus 6 squared minus 3 is equal to 22. So in this problem, I will need to type the equation into my Desmos graphing calculator. So I've kind of already done that. I put x minus 6 squared minus 3. And I forgot the y this time, but you'll notice it didn't matter. It still graphed that function, even without the y. And on the second one, I put y equals 22. Now, if you just graph that, you probably won't see this horizontal line. That's because you really have to go out quite a bit. So zoom out like this if you're on a phone until you can see the two graphs. And then you want to highlight your points of intersection, which is kind of hard to do because that's close to that Y-intercept. But there we go. So one of our solutions is going to be x is equal to 1 because the point was 122. And the other solution is x is equal to 11. So I'm going to put my graph first. So here's my x and my y-axis. And then I'm going to put my parabola, which is really tall this time because I had to go all the way up to that 22. So this isn't very accurate, but that's okay. And then the horizontal line I'm going to draw way up high, so we'll put one up here. So let's label these 2 points of intersection because that's where I'm going to find my solutions. So the first point of intersection is 122. So that's that one. And then this point of intersection is 1122. And that's telling me that the solutions, the two solutions to this equation are x is equal to 1 and x is equal to 11. So let's write both of those down. X equals 1 and x equals 11. All right, now we're going to take that same equation and we're going to solve it algebraically, and then we'll have basically these here for reference because we should get those two answers when we solve this algebraically. So to start, I'm just going to write the equation over so that I have my equation right next to my work. So step 1 is we're trying to isolate the x. You can't take care of this minus 6 yet because this quantity is squared. But what you can do is take care of this minus 3 because it's outside the parentheses. So to take care of it, or to get rid of it, I should say, we would do inverse operations. And the inverse operation for subtraction would be addition. So let's do plus 3 here and plus 3 here. So when you add 22 and 3, you get 25. And I apologize for my camera. It just keeps wanting to focus for some reason. All right, so we have the quantity x minus 6 squared still. But now that minus 3 and plus 3 add up to 0. So I'll just wait until it clears, guys. Sorry. Is equal to 25. All right, the next step in the process is to take care of the square. So if the quantity x minus 6 is squared, to remove the square, we will do an inverse operation, square root. So square root both sides of your equation. When you square root, it's going to remove these parentheses, it's going to remove the square, and then all that you have left here is the x minus 6. Now on the right side, this is really important. We have to remember, we do not know if the number inside here was positive or negative because we squared it. And when you square something, it always comes out positive. So to fix that, we have to put a positive or a negative 5 over here. Because this quantity inside there could have been a positive 5 or it could have been a negative 5. We don't know. All right, next step is to add our 6 to both sides. And I'm going to go ahead and separate these out since we've already done a couple. I'm going to write x equals 6 plus 5 for the first one. And then I'll do x equals 6 minus 5 for the other one. Well, 6 plus 5 is equal to 11. So that would be the solution, x equals 11. And 6 minus 5 is equal to 1, so that would be my solution, x equals 1. So I did get the same two solutions when I solved algebraically. Question 4. This time we have a quantity x 1/2 times x plus 7 squared plus 1. To do the 1/2, I did want to show you that, so I'm going to go back and start over here. You would just simply do 1 divided by 2, and it will create the fraction for you. So if you're curious about that, they don't have alpha y equals inner like we do on the graphing calculator. You just do 1 divided by 2. And then in parentheses, we'll put the x plus 7. So x plus 7. And then close your parentheses and do your square. And you still have a plus 1. All right. So there's my parabola. I didn't even put the y equals, and it puts it, which is kind of nice. So I'm going to come up here and move my graph over. You can close those off. I do have my 9 in there, by the way. I didn't show you. I didn't just type it, but it was there before. I put it before we started. So let's go ahead and find the points of intersection for the parabola in the horizontal line. And these are my points. So my x coordinate for the first point is -11, so that's one of my solutions, and my x-coordinate for the other one is -3. So I'm going to make a real quick sketch of what I'm seeing. So I have a parabola, and it is not crossing the x-axis. That's kind of interesting. So it's over here, and then it's got a horizontal line up at the 10, so I'm going to draw a horizontal line up here somewhere. And then I'm going to label these two points of intersection. So one was -11, 9, and the other one was -3, 9. And that's this one. So now my solutions are x equals -11 and x equals -3. So let's write that down. X equals -11, x equals -3. All right, finally I need to solve this equation. So I'm going to rewrite the equation over here to the right so that my equation is next to my work. And I am going to kind of not write every little step here just to conserve on space, but you can use separate sheets of paper for any of these problems. So feel free to use as much paper as you have available to do this problem. All right, so step 1, I'm going to subtract 1 from both sides of this equation. So that will change, this 1 will disappear basically when I subtract 1, and this 9 will become an 8. So the next step will be 1/2 times x plus 7 squared equals 8. Now here I'm dividing by 2, because when you multiply by 1/2, you're actually dividing by this 2. So I think I will write this step. I'm going to multiply both sides of the equation by 2. When I multiply by 2, 2 times 1/2 is just 1. So you don't even have to write the 1. You can leave that off and just write your binomial squared. So we'll get x plus 7 squared equals 16. The next step is to take the square root of both sides of the equation. So when you take square root of x plus 7 squared, you just get x plus 7. And when you take the square root of 16, don't forget you need a plus and a minus, because you could have a positive 4 that was squared in here. And you could have a negative 4 squared in here to get your 16. So this number inside was either a positive or a negative 4. And then finally, you're going to subtract your 7. So x equals negative 7 plus or minus 4. Now let's see if these answers here match the ones here. So we'll start with negative 7 plus 4. Well, negative 7 plus 4 is equal to negative 3, so that one works. And the other one is x equals negative 7 minus 4, and that one works too, because that one's equal to the negative 11. Okay, for question 5, we will be using the zero product property. The zero product property states that if you have the product of 2 or more factors, then at least one of those factors must be equal to 0. Let's think of it this way. If I multiply 2 times 3 times 0, that 0 will make the product equal to 0. So that's kind of the idea behind the next 4 problems. In these problems, we are going to use graphs to identify solutions, same as before, and then we're going to solve them algebraically by using the zero product property. So notice these equations are now in factored form. They are not in vertex form, but it doesn't really change how we start. We're going to type in this expression for our y1. You could put y equals or not. The y is optional. But when you type this, it's going to produce a parabola. Now something different here is the right side of the equation is just 0. So you could put 0 in the second row, but you don't really need to do that, because if you were to go up here and click on your graph, it will automatically put these X-intercepts on this graph. So you do not have to type the 0 because those points will show up no matter what. So I'm going to skip that step and just type in the left side, since these are all equal to 0 to start. In future lessons, we'll have some that are not equal to 0, so we'll have to do something else on those like we did on the first one. So step 1, I'm going to sketch this graph. And I'm going to sketch my parabola. And so you'll notice this parabola intersects the x-axis in 2 places. So I've got a parabola that comes down and back up. And so what I really want are these x-intercepts. So this x, and I'm just going to write the x-intercept and not put the 0. But if you want to put negative 5, 0 and 3, 0, you certainly may. I'm just going to write the x coordinates because those are the solutions. So I already have my solutions to my equation. And so next we're going to use the equations and solve, and it's a pretty simple process. You take each of your factors and you set them equal to 0. But the problem is 1/2 is not equal to 0. So if you want to write 1/2 is not equal to 0, you can, or you can just skip the 1/2 because obviously that is not a 0. But either one of these could be 0. So we need to set each one equal to 0. So x minus 3 is equal to 0, and x plus 5 is equal to 0. Now to solve these equations, you would add your 3 to both sides. So I'm going to do plus 3, plus 3. And the negative 3 and the positive 3 will give you a 0 because these are opposites. And 0 plus 3 will give you 3. So this solution is x is equal to 3. And you will notice it matches the x is equal to 3 that was on this graph. All right, for this one, we will subtract the 5. So minus 5, minus 5. Negative 5 and positive 5 add up to 0. So you get x equals 0 minus 5 is negative 5. So you get x equals negative 5. And this is your other solution. Question number 6. We have the quantity x plus 1 multiplied by the quantity x plus 4, and that is equal to 0. So again, I've typed in x plus 1 times x plus 4 into my Desmos graphing calculator, and it has produced this graph. So up here, if you will click or just tap on those x coordinates, you will see that your two x-intercepts are x equals -4 and x equals -1. So I'm going to make a quick sketch of what I'm seeing here. And so my x-intercept for my parabola, they're both over here on the left side. So this one's x equals -4, and this one's x is equal to -1. Now we're going to use the zero product property to solve this equation. So to do that, we take each of our factors. The first one is x plus 1, and set it equal to 0. So x plus 1 equals 0. The other factor is x plus 4, so we'll put x plus 4 is equal to 0. And then we will solve each equation. So to solve this equation, we subtract our 1, and we get x equals -1. And for this equation, we subtract our 4, and we get x equals -4. So as you can see, that answer is here and here. So you can kind of check your answers by looking over here and making sure these answers are the same answers that were on your graph. Question 7. 1/3 multiplied by the quantity x minus 6 multiplied by the quantity x minus 2 is equal to 0. So I've typed this entire left side of my equation into my calculator, and notice it's produced this parabola. So in the parabola, you'll actually see these points already kind of highlighted for you. The two I care about are my x-intercepts, so let's see if we can tap on those to get our points. So the first x-coordinate is x equals 2, because it crossed at 2, 0. And the other x-coordinate is x equals 6, because it crossed at 6, 0. So I'm going to go ahead and put a little sketch of this parabola. All right, so it crosses twice over here on the right side. Don't spend a long time trying to make these look really nice. You can tell I'm not doing that, so it's really okay. As long as I can read the numbers that you're getting here, those are the most important pieces that you want. So the first one was x equals 2, and the other one's x equals 6. So using the zero product property, remember before we had that 1/2. Well, 1/3 does not equal 0, so you don't really need to write that. But you do need these two. This factor could be 0 because you have a variable in it. So we'll write x minus 6 equals 0. And the other factor was x minus 2, so that's x minus 2 equals 0. And then you can solve each one. So if you add 6 to both sides, you're going to get x equals 6 for this one. And if you add 2 to both sides, you'll get x is equal to 2 for this one. And again, those matched the two solutions I already had, so I'm going to put little check marks because these checked. They gave me the same results. Question 8. -2 times x minus 1 times x plus 2 equals 0. So I've typed the left side of the equation into my Desmos graphing calculator, and I've highlighted both of my x-intercepts. And so I'm going to make a sketch of this graph. Again, focusing on those two x-intercepts when I make my graph. So it does cross the x-axis twice. So I'm going to make my parabola. And then I'm going to label my x-intercepts. X equals -2 and x equals 1. Okay, next, let's solve this algebraically. And to do that, we simply set each of our factors equal to 0. You do not need to set -2 equal to 0 because it's not 0, so it's not one of our possible zeros. So we'll take x minus 1 and set it equal to 0, and x plus 2 equal to 0. And then subtract, or excuse me, on this one, you'll add 1 to both sides, and you'll get x is equal to +1. And this one, you'll subtract 2 from both sides, and you'll get x is equal to -2. And as you can see, both of those are the numbers in our graph. So x equals 1 was here, so that one works. And then x equals -2, that was here. So I am seeing those solutions in my graph. Now we're going to look at a vertical motion problem, and this has to do with throwing an object up into the air. You may see problems like this talking about throwing a football or some other object. They all kind of work the same way. The quadratic equation that we have here, we are going to graph that in our calculator and analyze it to answer this question. So it says an object is thrown up and is allowed to fall back down to the ground. The height of an object in feet is a function of time in seconds, x. So that's telling you these x's in this function, this x and the one in the parentheses here, those are your seconds. And the height of the object, which is your h, represented by h, is going to be the output of the function. So the output would be the height of this object. So step one, let's type in the function, and you do want to put h of x, because we do want to put, so hit the ABC button at the bottom to get your alphabet, and so you can put H and then close that by pressing 1, 2, 3, and so we'll put X inside our parentheses, and then put your equals, and then type in your function. So we have negative 16, open parentheses, X minus 1.5, and then close your parentheses and square. And then finally, you want plus 48. Now, this window is not the greatest because as you can see, we do have a parabola. I'm going to close this for a minute so I can see this better. But you'll need to zoom way out to see the top of that. And really, I don't want to zoom out. I want to just change the window to make it look prettier. So let's press the wrench on the top corner. And then we can adjust our x's and our y's. Now our x's are probably too big, so I think I make this negative 1. And then it looks like it only takes a few seconds, so maybe make this 5. And I'll count by ones. For my y values, it's going to go way up there. So let's see how far up we want to go. How about negative 10 to... why it won't keep staying there. Let's see. How about 80? We'll try that. And it may not be good. We'll change it. Sorry, my calculator's jumping all around here. I'm going to go ahead and put my x in that box, and I can put h of x here, or just put y. That'll work. Since I'm going to 80, I'm going to count by tens. And I'm also going to remove my minor grid lines because I don't really want so many lines on my graph. Now, when you get all that, let's look at it and see what we got. Oh, that looks pretty good. Now, it did go up to 80, which is kind of overkill, but I like this graph, so I'm going to leave it. Now, the first question in these questions says to graph the function, identify the vertex. Well, if you'll tap on the parabola, it'll show the vertex. So if you'll tap again, it'll give you the ordered pair. So what we're going to do is sketch this graph. And just like before, we really don't want to put too much detail on this graph. Just the main points, which would be my Y-intercept, this X-intercept, and that vertex. So those are the points that matter. And please be sure to put labels on your graph. So this is X and H of X. The X is the time in seconds. So I'm going to put seconds down here. And the height is in feet. So I'm going to put the unit. You could put both, actually. Height in feet, time in seconds. That would be nice. And then I do have an intercept here at the 12. So you can write the order pair 0, 12, or you can just put a 12. And then the parabola goes up and back down. And then we're going to put this vertex. So the vertex is the point at the top. So let's write the word vertex so we can identify. And then let's write the ordered pair 1, 5, comma, 48. I'm going to go ahead and label this too. This number here was 3.232. So you can write the ordered pair the way it's presented on the screen here, or you can just write that number. Both would be okay. All right, so we've graphed the function and we've identified the vertex. So what does this vertex mean? Well, remember the x was the number of seconds since the object was released up into the air, and then the y represents the height of that object in feet. So this 1.5 is telling us it takes 1.5 seconds. So it takes 1.5 seconds for the object to reach a maximum height, because this is the highest point on this graph, of 48 feet. Question 10. What is the y-intercept of the graph, and show how to find this answer algebraically? What does the y-intercept mean in this context? Okay, well, the y-intercept of the graph we've already labeled above was the 12. So we need to write y is equal to 12 for the answer. So how do we find that answer algebraically? In other words, how do we use the equation to find this answer? So back at the top of this problem, we have this equation. So to find the y-intercept, you basically replace the x in your equation with a 0. So we'll put a 0 in place of the x. So this is how you do it algebraically. Now you can take your time and do this out long. So you would subtract these two numbers, get negative 1.5, square that answer, multiply by the negative 16, and add the 48. Those are your order of operations. So parentheses, then your exponent, then multiply, and then finally you would add your two results. So what I'm going to do is basically type the whole expression into the calculator. So if you'll go back to your calculator, tap on 2, you can type this entire expression in the calculator. So I've got negative 16. Oh, wait a minute, I need a negative, not an equal sign. Oops. Negative 16, open parentheses, 0 minus 1.5, close parentheses, square that, and then add 48. And so when you press enter, you don't even have to press enter. It's going to display the result 12 on your screen. So h of 0 is equal to 12. Another thing I want to show you, and I need to make sure I didn't mess up my equation up here, because I've got to use it. So we have our equation here. Let's include the h of x this time. So I'm going to have my h of x. I think I already had that, but I deleted it somehow. So let me put it back. All right, so h of x equals negative 16 times x minus 1.5 squared plus 48. So what I want to do is h, so let's do h of 0. And notice it gives me the output 12. So I can do this manually by just typing out this expression, or I can type in a 0 for the x and it will give me the output 12. So either way, that's finding it algebraically. All right, what does the y-intercept mean in this context? Well, you'll notice that the graph begins at this point, because this would be the height of the object when it was released. So the y-intercept is time is 0 seconds, height is 12 feet. So let's write that, 0 seconds, 12 feet. So that's your ordered pair, and that means the object was released at 12 feet. Or it was released at a height of 12 feet. So that's what it means. Okay, so what is the positive x-intercept of this graph? So our last question is, what is the positive x-intercept of the graph? Show how to find this algebraically, and what does it mean in this context? Well, if you go back up here to the graph that we've made already, We already had the the X-Intercept right here, actually, 3.232. So I'm going to write what is the positive X-Intercept. It's approximately, because this answer, believe it or not, is not an exact answer. It's been rounded off. The calculator does that automatically when it displays these decimal numbers. So in general, you're going to know this is a rounded answer when you see an answer like that. All right, now show how to find this answer algebraically. So go back to your original equation. So in the original equation, we have this function. Well, what we want to know is where this function is equal to 0. So we're going to set this function equal to 0. So using what little space I have here, let's put negative 16 times x minus 1.5 squared plus 48 is equal to 0. Now to find this algebraically, we're going to do the same thing we did on the very first page of the assignment. We're going to isolate this x. So don't do plus 1.5. You can't square root, and you don't divide, but you do go ahead and subtract this 48 first. So when you subtract 48 from both sides, you'll get negative 16, so this stays. X minus 1.5 squared, that stays. But the plus 48 will be gone because you subtracted it, and on the other side of the equation will be a negative 48. Okay, the next step in the process is to get rid of this number that's multiplied by this quantity. We can't take the square root yet. Actually, we could, but it would be much more challenging. We definitely don't want to add a number because this is in the parentheses. So we're going to take care of this next by dividing out negative 16. So if I divide by negative 16, it will remove the negative 16. It will not remove the parentheses. It will not remove the square. And when you divide negative 48 by negative 16, you actually get a positive 3. All right, so the next step is to remove our square, or do the inverse operation for squaring. So that would be taking the square root. So I'm going to take the square root here and here. Now, important thing to note here is it said find the positive x-intercept of the graph. So you will not need the negative square root of 3 here. So we're not going to put a negative square root of 3 here. We're just going to put square root of 3. Also, square root of 3 is not a rational number. So we're not going to put a decimal just yet. Let's go ahead and put the square root of 3 just like that. And then on the left side, we've removed our parentheses and the square. So the last step is to add 1.5 to both sides. And so that will give me 1.5 plus the square root of 3. All right, now that answer doesn't look anything like 3.232, but that's because it's got that square root in there. So what we will do is use our calculator, and you can go to the next row, or you can just delete what you got and type this in. I'm going to type 1.5 plus square root, and there's a button for that. Whoops, I hit it too many times, of 3. And look at that. It gave me the decimal, 2.232, and a lot more digits. So now you can really see that that was a rounded answer. So the correct answer was 3.232. So I'm going to write that here. This is approximately 3.232. All right, the last step is to say what it means in this context. Well, if you'll go back to the graph, I think this will help. In the graph, notice this represents the number of seconds. So this is 3.232 seconds. And the height, well, the height is 0 because if you think about it, your y-coordinate on this axis is 0. So that means this object will reach the ground in approximately 3.232 seconds. So let's write what it means in this context. So the object reaches the ground in 3.232 seconds. Or it falls to the ground, or it's on the ground. So something similar to that. And I apologize for my handwriting, so hopefully I'll read that. The object reaches the ground in 3.232 seconds. So, in summary, today we solved quadratic equations. We first used graphs to identify solutions, and then we solved them algebraically. First, by isolating the x by using inverse operations. And second, then we used the zero product property for equations that were in factored form. And then finally, we solved a real live situation here. We used a real graph for an object thrown up into the air to locate the vertex, the X-intercept, and the Y-intercept, and then to find that Y-intercept and X-intercept algebraically. Continue to practice until we meet again.